So what goes wrong in the process of applying the quadratic formula? Let's look at the first example up here. This is the team number 1 up here in the front corner. X squared minus 2x plus 5 is equal to 0. So to use the quadratic formula for this equation, what did you do first?
This is we just plugged everything in. We figured that we know that our A was positive 1,
Okay.
B was negative 2, and C was 5.
Okay, so by the way, that very step at the beginning of the problem of identifying A, B, and C is also a place where it's easy to kind of screw some stuff up sometimes. So just in that identification process, remember that A, B, and C are always numbers. They don't have x's or x squareds or anything with them when you use the quadratic formula on a quadratic like we're solving. So there are no x's in the formula when you use A, B, and C. Also, watch the signs. Watch for that minus sign, for example, on the negative 2 that you use here on B. It's a negative 2 because that is the coefficient of the x in this expression on the left-hand side. Okay, so you identified A, B, and C. There are those numbers, 1, negative 2, and 5. And then you did what?
Plugged in, basically.
Yeah, I just plugged it into the quadratic formula. So, so let's see. That begins with negative, not negative, I want to say opposite of B. So minus negative 2, plus or minus the square root of B squared, and then minus 4AC. A here was 1, and C was 5. And I'm going to have a fraction bar problem 2 here, unless I also extend this out. And then on the bottom I have 2A, that's 2 times 1. And then you went along and evaluated this. Before we go any further, though, I want to point out one more thing that I told a number of your groups as I walked around and looked at your work on these problems. So B here is negative. So what happens to this first term in the numerator? Minus B. What's that going to become? Yeah, minus B is going to turn into a positive. So that's one thing to note. If B is positive, minus B is negative, and vice versa. If B is negative, then minus B becomes positive. Minus B is positive. So that's definitely something to look for. And a second thing, underneath the radical here, I have negative 2 with an exponent of 2 sitting next to it. And that's exactly the kind of expression that I try to call you out on every exam. Is that going to evaluate to positive 4, or is it going to evaluate to negative 4? What do we want it to evaluate to? What we want to happen in the quadratic formula is we want to square the number b. But the number b is negative 2 in this example. So we want to square negative 2. In other words, we want to multiply negative 2 by itself. If I just write it the way it's written up here, what's getting squared? If I don't do what you suggested and I just leave it this way, what are we squaring there, Sean?
Just negative 2 times 2.
Yeah, right. If I leave it the way it's written up here, the 2 is getting squared, but that minus that's out in the front, which serves as multiplication by negative 1, in the order of operations, that happens after the square operates on the 2. That's not what we wanted. We want negative 2 to multiply by itself. And this is one of the biggest sources of sign error. It's not the biggest, but it's certainly one of the biggest sources of sign error in applications of the quadratic formula. So the recommendation, anytime you substitute a number, but particularly when substituting negative numbers, hug them with parentheses. When substituting negative numbers, use parentheses. Because if you leave the parentheses out, then you're either not saying what you mean, or you're going to make an error that leads to a sign problem later on down the line. So that negative 2, surround it with parentheses because the whole thing needs to be squared. And with that, I think we're ready to carry out the rest of this arithmetic. So what is negative 2 the quantity squared, the way that it's written up here? 4. So we'll end up under the radical with 4 minus 4 times 1 times 5, that's 20. So 4 minus 20 under the radical, plus or minus. What did we decide minus negative 2 was? Positive 2. Downstairs, 2 times 1 is going to give me a 2. Okay. So then, underneath the radical, 4 minus 20 turns into negative 16. All right, so now this group that worked on this problem, what happened next for you? Emma?
You really can't go any farther because there's a negative sign.
Great. So that is the intrinsic problem with this application of the quadratic formula. There is possible extrinsic problems that you can introduce by screwing things up, but fundamentally, this quadratic formula has a real problem. And that pun is slightly intended, I suppose. The square root of the number negative 16 is what? Yeah. It's not a real number, and why not? How come the square root of negative 16 is not real? Let's think about that for a second. You can't square root a negative. Why not? How come we can't take the square root of negative 16? If you're not thinking too hard about that, what would you guess the square root of negative 16 would be? Negative 4. That's a possibility, right? So why is the square root of negative 16 not negative 4? What if it were? Let's just follow that line of reasoning for a second. If I claim that the square root of negative 16 is negative 4, then what has to be true about the relationship between the number negative 4 and the number negative 16? No?
Then if you squared 4, then it would, negative 4, then it would be equal to negative 16.
Yeah, exactly. If we say that the square root of 16 is negative 4, that means that negative 4 squared would have to equal negative 16. But what is negative 4 squared? Positive 16. So it doesn't work. Think about it. When you square a real number, you're multiplying it by itself. If that number is positive, then what you get is going to be positive times positive, and positive times positive is positive. If that number in the beginning is negative and we square it, then when we square it, we're multiplying negative by negative. And negative times negative is positive again. That's the problem, right? Anytime we square a real number, we get an answer which is non-negative, necessarily. So it's not possible for a real number to multiply by itself and give us a negative answer. So the real flaw in this quadratic equation is that the square root of a negative number, anytime there's a square root in the bottom, I'm going to agree with what Emma said in the beginning, that means that we pretty much are done. Square root of a negative number is not real. And that means that you can stop. At least as far as our course is concerned, we're not going to care about anything that might come after that. Stop and say that there are no real solutions. So in example number 2 here suffers from the very same problem that example number 1 had. Underneath the radical was a negative quantity, negative 3. And so no matter how hard we try, we're not going to get a real number answer out of this quadratic equation. No real solution. So both of these first two examples illustrated the same fundamental issue with the quadratic formula. Because of the presence of that square root in the quadratic formula, we can't be guaranteed that this formula will always give us real answers. If that quantity under the radical is negative, we have no real solutions whatsoever. And at that point, we can just wash our hands of it, at least as far as our class is concerned. And then we move along to team 3. So what happened that was weird for you when you solved the equation 4x squared minus 12x plus 9 is equal to 0?
Well, under the radical sign, we got the same number, so it equals 0.
Oh, all right. So underneath your radical sign, I'm just going to kind of look ahead here. You ended up with what number under the radical?
144 minus 144.
144 minus 144, which you said correctly evaluates to 0. So this is something different. We'll fill out the rest of these details in a minute. Because underneath the square root is not a negative, at least we know there's going to be some real solutions to this equation. It's just a matter of what they are. So let's go through and do. A is 4. What's B? Negative 12. C is 9. And so when you did your quadratic formula, you ended up with minus b, which again, because b is negative, minus b is positive 12, plus or minus the square root of b squared, and since b is negative, again, those parentheses are meaningful, minus 12 squared, minus 4a, which is 4, and c is 9, and divided the whole thing by 2a, which is 2 times 4. Okay, let me finish my radical bar up here. And yeah, sure enough, when you evaluate this quantity underneath the square root, negative 12, the quantity squared, is 144. 4 times 4 times 9 is also 144. And so underneath the radical, you end up with a 0. 12 plus or minus the square root of 0 all over 8. Okay, so then what happened?
Oh, well, I don't know. And then when you like separate it, you get x equals 12 plus 0 over 8, and then x equals 12 minus 0 over 8, but like because it's 0, it does nothing, so you just get 1.
Perfect. Couldn't have said it better myself. So getting a 0 underneath the radical does something different than when you have a positive number underneath the radical, right? When we choose the plus sign and when we choose the minus sign, we end up getting, on the one hand, because what is the square root of 0? 0. Yeah, the square root of 0 is 0. So on the one hand, we have 12 plus 0 over 8. On the other hand, we have 12 minus 0 over 8. And those are, supposedly, our two solutions. But when you follow through the rest of the logic, as you say, adding and subtracting 0 really does the same thing, which is nothing to those quantities in the numerator. So on the one hand, our solution is 12 over 8, and on our other hand, the solution is 12 over 8. What is 12 over 8 in lowest terms? What'd you get?
I got 1.5 and then 3 over 2.
1.5, 3 over 2, however you like it, right? So what can we take away from this example? What's going to happen when 0 is underneath the radical in the quadratic formula? Yeah, it cancels out in what way?
Two of the same answers at the end.
Yeah, we get 2 of the same answer. I'm going to write it that way because that's got all the meaning that we need in it. So when 0 is underneath the radical, the 2 answers are the same. The 2 solutions are identical. And so in a sense, there's not really 2 solutions. There's really just one. I won't mark you off if you decide to say that there are 2 solutions, 3 halves and 3 halves, or if you prefer to just say that there's one real solution to this, and that's 3 halves. That's fine with me too. Okay? So getting a negative under the radical is really bad. It means that there are no real solutions at all. Getting a 0 underneath the radical is good in a way. It tells you that there's real solutions, but how many real solutions? Just a single one, when the number under the radical is 0. We'll wrap up with our last example here, number 4. 7x squared minus 10x minus 1 is equal to 0. So the team that worked on this one, what was weird about this example? So team 4 says that what's weird about this example is that your answers are not going to be whole numbers. Now, that's not super duper weird because example number 3 came out with a couple of solutions that were not whole numbers, right? 1.5, as Brittany was saying, right? 3 halves. That's not a whole number. But there's something even less wholesome about the solutions to number 4. Let's look at what that is. So first thing we need is minus b. And since b is negative 10, again, minus b is positive, so 10. Plus or minus the square root of b squared. Again, surrounding negative 10 in parentheses. minus 4 times a, which is 7, times c, which is negative 1. And by the way, I'm going to take a moment here to pause and point out that one of the other most common sources of sign errors in the quadratic formula is, see where we have a negative product here and then a subtraction sign in front of it? By the time we simplify all of that out, minus a minus turns into a plus. Right. When I multiply 4 times 7 times negative 1, I'm going to end up with negative 28, but then I'm going to be subtracting negative 28. So underneath that radical, what I really have, just to skip ahead a little bit, is going to be 10 plus or minus the square root of 100 minus negative 28, but minus negative 28 is the same as plus positive 28. So very common source of sign error in the quadratic formula. The most common, I would say, source of sign errors in the use of the quadratic formula. And then downstairs we have 2 times 7. Okay, well that's all well and good, but that means that underneath the radical is the number 128. Now 128 is a number that has a lot of nice factors. 2, 4, 8, 16, 32, 64. Actually, that's it. That's a lot of factors. But what happens when you try to take its square root? It's not a perfect square. So I would say that's the weirdest thing that happens in this example. 128 is not a perfect square. But because it's a positive number, at least, if we were to just take the plus and take the minus, how many real solutions are there? 2. Even if they're not nice whole numbers, they're still real numbers. And if you want to, you can come up with a decimal approximation. If this were my exam and this showed up, I would say you can just leave it the way it's written here. We could simplify out the radical if we want to and make a little headway that way. But the fact is that there's 2 real solutions
So like on the
in this
homework,
example.
how are we supposed to write